combination of resistors and cells. Okay, everyone. Duster, please. Right, okay. Getting your voice. Right. So, worksheets. Okay, fine. I'm going to dictate the questions. Yes, guys, write down. So we'll do few questions based on combination of resistors, combination of cells. Combination of cells. So write down the question. First question is, two batteries of different EMF, two batteries of different EMF and internal resistances two batteries of different EMF and internal resistances connected in series with each other, and with an external resistor Full stop. I'm repeating this once again. Two batteries of different EMF and internal resistances connected in series with each other and with an external resistor. Full stop. The current is 3 ampere. Full stop. When the polarity of one battery is reversed, the current becomes 1 ampere. Full stop. The ratio of the EMFs of two batteries is EMFs of two batteries is. Copy. Right. Let us see quickly what is given and what we are asked to find. See, it is given that two batteries of different EMF are connected in different EMF and internal resistances are connected in series with each other. Let's say there is actually question number 22, level 2 exercise 2. Two batteries of different EMFs, let us say E1 and E2, with internal resistances R1 and R2 are connected in series with each other, and with an external resistor also, with an external resistor, let us say R, so that now a current of I is equal to 3 ampere flows in this. I is equal to 3 ampere flows in the circuit or the load resistor. Whereas when the polarity of one battery is reversed, that means now this is positive, negative, positive, negative. Let us say this polarity is reversed. Let us say like this. There is one and this is the second one. This is E1 and this is R1. This is E2, R2. And into the same load resistor, an external resistor of resistance R. Now a current of, depending on the larger one, you can see the current of how much? Let us say this is I1 is equal to 3 ampere, and now I2 is equal to 1 ampere is flowing. So that is the case. What is the ratio of EMFs of the cells? So what you can understand is, in this case, these two are in series. And the current due to this is in this direction, current due to this also will be in this direction. They are in supporting manner. Means net EMF of the two cells in series will be directly sum of the EMFs. So, and hence you can say current I in the circuit is equal to net EMF by total resistance. Right? Here net EMF is nothing but sum of the EMFs E1 plus E2 by total resistance is what? R plus R1 plus R2. R1 plus R2 plus R. Either way you can take R plus R1 plus R2 is total resistance, because all are supposed to be in series. So in this case current is given as 3 ampere. So you can write this as E1 plus E2 by this is equal to 3. Got it? So 3 is equal to E1 plus E2 by R1 plus R2. Let's say this is equation 1. Whereas when the polarity of one cell is reversed, the current of 1 ampere is flowing in the circuit. That means again in this case I is equal to net EMF by total resistance. Net EMF is, because they are with reverse polarity, larger one minus smaller one, you can say E1 minus E2. Okay? So it is equal to E1 minus E2 divided by total resistance is same, R plus R1 plus R2. So where EI is 1, so you can write it as 1 is equal to E1 minus E2 by R plus R1 plus R2. Let us take this expression. But this is given. We are asked to find the ratio of. We are asked to find E1 by E2 is equal to what? How to find? Yes? How to find by using this? So let us divide these two equations. Let us divide these two equations. You have to think about by adding, subtracting, which possibility you can do. So that first of all, this is okay. Resistance is R plus R1 plus R2. So if you observe here, resistance part is same in both cases. So if you, and these values are not given. So if you remove this, only E1, E2 form, you will get the expressions. Then you can take the ratio of the E1, E2s. So for that purpose, let us try to divide these. Then what you can say, either 1 by 2 or 2 by 1. 1 by 2 implies the left side is 3 by 1 is equal to E1 plus E2 by R plus R1 plus R2 divided by this. So what you can write into R plus R1 plus R2 divided by E1 minus E2. This part will get cancelled. Now we will get E1 plus E2 by E2, E1 plus E2 is this, or a cross multiplied. So this implies, you can write it as 3 into E1 minus E2. So 3 E1 minus 3 E2 is equal to 1 into E1 plus E2. So E1 plus E2. Is this step clear? Next, you can write, you bring this here and you send this here. So 3 E1 minus E1. 2 E1 is equal to 4 E2. We are asked to find E1 by E2 or E2 by E1? E1 by E2. So if that is the case, you can take E1 by E2. Here you can cancel for that. 2 ones, 2 2s. So E1 equal to 2 E2 or E1 by E2 is equal to 2 by 1 or 2 is to 1. What is? So you have to think about what kind of simplification you have to perform. Let's do it fast. Finished? Next question. Write down the next one. The PD across, next question. The PD means potential difference. The PD across terminals of a cell, the PD across the terminals of a cell is found to be 29 volt and 28 volt respectively. 29 volt and 28 volt respectively when it delivers a current of 1 ampere and 2 ampere respectively. I am repeating, the PD across terminals of a cell is found to be 29 volt and 28 volt respectively when it delivers a current of 1 ampere and 2 ampere respectively. Full stop. The EMF and internal resistance of the cell are, the EMF and the internal resistance of the cell are right. So can I erase this? So you can write down the given conditions, the given data. Yes. It is given that the potential difference across the terminals of a cell is found to be 29 volt and 28 volt when it delivers a current of 1 and 2 amperes. Means potential difference is 29 volts when it delivers a current of 1 ampere and 28 volts when it delivers a current of 2 ampere. So this you have to take separately. So if you have a cell This is question number 23. Level 2, exercise 2. Right? So the PD across the terminals of a cell is, you can take it as when it delivers a current of, let us say, I1. So the potential difference is V1. When it is delivering the current, means when drawing the current from this, when you are drawing the current from this, you can say it is delivering current. Potential difference is equal to E minus IR. Got it? So in this case, so cell is same, so EMF will be same, internal resistance will be same. But when it is delivering this current I1, potential difference is V1. When it is delivering current I1, potential difference is V1. Whereas when it is delivering a different current I2, as EMF is same, internal resistance is same, then potential difference will be different. So it is equal to what? E minus I2R. Right? So in this first case, potential difference is 29 volts when the current delivered is 1 ampere, 1 into R. Is it clear? And the potential difference is 28 volt when the current is 2 ampere. Is this clear? Then what is EMF and internal resistance? So you can add or subtract, or you can write the expression for E and equate and eliminate one. So anything you can do because it is E and E. So if you subtract, E gets cancelled, right? So let us say this is 29 is equal to, or you can write E is equal to 29, 1 into R is R, minus R if you come here, it becomes plus R. This is E is equal to 28 plus 2R, 1 and 2, both are E's, so equate them. So you get 29 plus R is equal to 28 plus 2R. So send this R this side, send this side. So 2R minus R, 29 minus 28, 1. So internal resistance is 1 ohm. Is this clear? Yes, everyone? Once you know internal resistance, substitute this in equation 1 or equation 2, you will get EMF. So let us say from 1 implies E is equal to 29 plus 1 is equal to 30 volts. That's it. Got it? Next. We have to copy simultaneously, guys. You shouldn't waste time. Finished everyone? Has any confusion? Has anyone? Next question. Let's write down. The current in a circuit containing a battery, connected to 2 ohm resistance, is 0.9 amp. 0.9 amp. Full stop. 0.9 ampere. Okay, full stop. When the resistance of 7 ohm connected to the same battery, when the resistance of 7 ohm connected to the same battery, when resistance of 7 ohm connected to the same battery, the current observed in the circuit is 0.3 ampere. Full stop. Then the internal resistance of the battery is right. Yes guys. So what is given here and what you are asked to find. Question number 24. So what is given? What is given? The current in the circuit containing a battery connected to 2 ohm resistance is 0.9 ampere. There is a battery is connected to a resistor. When the resistance is 2 ohm, let us say R1 is equal to 2 ohm, and this battery is having some EMF E and internal resistance R. So when it is connected to 2 ohm resistance, the current I is what? You can say I1 is equal to 0.9 ampere. So R1 is equal to 2 ohm, I1 is equal to 0.9 ampere. Right? Whereas when the same cell is connected to 7 ohm resistance, current is 0.3 ampere. When this is connected to R2 is equal to how much? 7 ohm, then I becomes different. So it is having some EMF and internal resistance. So here this is equal to 0. I2 is equal to 0.3 ampere. 0.3 only? 0.3 ampere. The internal resistance of the battery is what? What is internal resistance? That is the case. And if here R2 is equal to, if R2 is equal to 7 ohm, I2 is equal to 0.3 ampere, then what is internal resistance of the cell or battery? What is internal resistance of the cell or battery? So how do it? So we can say E or what is that? I is equal to net EMF by total resistance. So in the first case, I1 is equal to EMF is E by total resistance is R1 plus small r. It is equal to E, we don't know. E, we don't know. R1 is 2 plus small r. Right? And I1 is 0.9. So from this you can write E is equal to, what is this I1? 0.9 into 2 plus R. Let's say this is equation 1. Whereas when it is connected to this resistor, same. I2 is equal to E, same E, by total resistance is R2 plus small r is equal to E, or you can say here I2 is 0.3 is equal to E by 7 plus small r, or E is equal to cross multiply 0.3 into 7 plus small r, 2. Right? Same battery, EMF is same, equate them. So what do you get? 0.3 or 0.9 this into 2 plus r, you multiply and you can equate it also. 2 plus r is equal to 0.3 into 7 plus r. EMF is same. From 1 and 2. 1 and 2 implies E is same. So equate them. So and simplify. 0.3 once, 1 times. Point. How many times? 3 times. Right? So then you can write it as 6 plus 3r is equal to 7 plus r. You bring it here, you send this there. So it is 2r is equal to 1. 1 only. So r is equal to, so this implies r is equal to 1 by 2 or 0.5 ohm is internal resistance. So option 0.5 ohm. Got it? Next question. Note down quickly. So next another one is based on internal resistance only is given. In one question you can have the different way of working out. So by working out as many questions, you can get an idea of how can you deal. The equations are same only. I equal to net EMF by total resistance only. You can have to deal in different ways. Okay, that you can improve by working out the different questions by using different data, given data. Next, write down two cells of EMF, 3 volt and 5 volt. 2 cells of EMF 3 volt and 5 volt, and internal resistances R1 and R2, small r1, small r2. In the internal resistances R1 and R2 respectively, and internal resistances R1 and R2 respectively are in series with an external resistance capital R, in series with an external resistance capital R. Full stop. If the potential difference across first cell is 0, if potential difference across the first cell is 0, if the potential difference across the first cell is 0, then capital R is, so what is given? Right, can I erase this, everyone? Yes. So let us look into the given data and what we are asked to find once again. It is given that two cells of EMFs 3 volt, 5 volts and internal resistance R1 and R2 are given. They are in series with an external resistor. So there are two cells. Question number is actually 26th one. There are two cells. These having EMF E1, internal resistance R1 is in series with another cell having EMF E2, internal resistance R2. These are connected in series with an external resistor of resistance R. Is it clear? Right. It is given that here E1 is equal to how much? 3 volts. E2 is equal to 5 volts. If internal resistance are R1 and R2, what is the external resistance value in terms of R1, R2 guys? You can take the options. First option, 5R1 minus 3R2 by 3. Second option, 2R1 minus 3R2 by 4. Third option, 3R1 minus 5R2 by 3. Fourth option, 4R1 minus 5R2 by 3. Yes. So, the load resistance value in terms of base. And one more condition is given, it seems. What is that? If the potential difference across the first cell is 0, potential difference across the first cell V is 0, then what is external resistance? So, what we have to understand here is, we know potential difference. Actually, they are connected in series. The current actually current this will flow to the left, this also flow to the left. They are in supporting manner. One thing is clear. Other thing is, you can say for the first cell, potential difference V1 as current is coming out, we are drawing out and is flowing. is equal to what you can say E1 minus I into R1. Got it? So, but for the first cell, the condition is the potential difference is 0, means this is equal to 0. It is 0, then you can write it as E1 is equal to IR1. IR1. From this you can write, this implies I is equal to what? E1 by R1 can you say? Yes, if we need, we can make use of that. So let us keep it aside. Next, V2 is equal to what? For the potential difference across this, as current is coming out here, E2 minus IR2. Let's say this actually this is 1, this is 2, R is 1, this is 2. Either way you can give the names. But if you, what you are asking to find? Capital R. Is there any line capital R? No. How can you involve here? You have to get current, total current. You know total current I is equal to net EMF by total resistance. You see the same formula in different ways we are using. Right. So what is the net EMF when two cells are connected in series? Of EMF values are given here. E1 and E2 are 3 and 5 volts, right? So it is 3 plus 5. Directly you can take, or if you want to write the formula, E1 plus E2 by R plus R1 plus R2. So E1 plus E2 is, what is this? Right, we can write it as I is equal to 8 by R plus R1 plus R2. Yes. Then here this and this are same. Should be same. You can say this is equation 3. I equal to E1 by R1 should be equal to this only, right? So you can equate this. So where E1 can also write it as E1 is how much? 3. So it is 3 by R1. So let us say this is 1. So from 1 and 3, you can simplify and get capital R. Let's do it. 1 and 3 implies 3 by R1 is equal to 8 by capital R plus R1 plus R2. So 8R1 is equal to, you can write 3 capital R plus 3R1 plus 3R2 is equal to 8R1. We want capital R. So send all these that side. So what do you get? 3R is equal to 8R1 minus 3R1. 5R1. 5R1 only minus 3R2. So R is equal to 5R1 minus 3R2 by 3. Yes? Is there any such option? Option number 1. That's it. Is it clear? Right. That's it. Do you have time? Yes. 4 minutes. Yeah. Can you wind up? Okay. So there are a few more similar and kind of slightly different kind of questions are there. So try to practice yourself the additional questions if possible. I don't know whether it is possible or not. When they said they will give tomorrow. Okay, try. For day scholars, the online students day scholars, I can send the questions by taking a pic. You can refer the questions, but residential students you have to go through yourself. Okay, right.